What if your AI assistant could roll dice for your tabletop game, calculate probabilities, or even simulate entire campaigns, all through a simple Python interface? We'll build a FastMCP server that exposes a dice-rolling tool to AI models, then show how Google's Gemini SDK can call it directly. You'll see the exact pattern for creating AI callable tools, from server setup to remote execution, in just a few lines of code.
Import random. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals dice roller. At MCP, tool. Def roll dice, end dice, int list int. Roll end dice, 6-sided dice and return the results. Return random, randint 16 for in range end dice. If name equals main. MCP, run.
This demonstrates the AI tool exposure pattern, where Python functions become directly callable by AI models through a standardized interface. The decorator approach transforms regular functions into AI-accessible tools while preserving their native Python behavior, creating a clean separation between business logic and AI integration. What makes this distinctive is how it bridges the gap between human-readable code and machine-consumable capabilities without requiring API boilerplate. The pattern works by using decorators as declarative markers that signal tool availability to the framework. FastMCP handles the entire RPC lifecycle, discovery, validation, and transport, while your functions remain focused on their core logic, unaware of how they're being called. This inversion of control means you define what the tool does, while the framework determines how it's exposed, enabling consistent interfaces across different calling contexts. This approach matters because it solves the integration complexity problem for AI-powered applications. Instead of building custom APIs or adapters, you write normal Python functions and let the framework handle the AI interaction layer. It's particularly valuable when you need to expose backend capabilities to multiple AI systems, or when you want to maintain clean separation between your business logic and AI integration points. The trade-off is framework dependency, but the productivity gain in AI integration scenarios typically outweighs this cost. Let's break it down line by line.
Import random.
Imports Python's built-in random module to generate pseudorandom numbers. This provides the randint function used later for dice rolls, ensuring unpredictable results within the specified range.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for creating AI callable tools. It transforms Python functions into structured tools that AI models can invoke with proper type safety and documentation.
MCP equals FastMCP. Name equals dice roller.
This instantiates the FastMCP server with the name dice roller, creating the central controller that will expose your Python functions as AI callable tools. The name parameter identifies this toolset in the MCP registry, enabling discovery and routing. This is the required entry point for all FastMCP-based tool implementations.
At MCP, tool. Def roll dice, end dice, int list int. Roll end dice, 6-sided dice and return the results.
The @MCP tool decorator exposes this function as an AI callable tool. FastMCP uses the type hints and docstring to auto-generate the tool's schema, including parameter validation and documentation. This is the standard pattern for defining tools in FastMCP. Decorator for exposure, type hints for validation, docstring for description.
Return random, randint 16 for in range end dice.
This is a list comprehension that generates end dice random integers between 1 and 6. It efficiently replaces a for loop to create the dice roll results in a single line, which is both performant and Pythonic. The underscore signals we're ignoring the loop variable since we only care about the count.
If name equals main.
This is Python's standard entry point guard. It ensures MCP, run, only executes when the script runs directly, not when imported as a module, preventing accidental server startup during imports.
MCP, run.
This starts the FastMCP server, exposing all decorated tools to connected AI models. Without this call, the tools exist but remain inaccessible. Standard entry point pattern for FastMCP applications. FastMCP tool decorator pattern. The MCP tool decorator transforms ordinary Python functions into AI callable endpoints, automatically generating schemas that bridge human code and machine reasoning. Tool names in the decorator become the permanent interface contract, so rename them carefully after deployment. This single decorator handles serialization, validation, and discovery without additional boilerplate.
The decorator that names the tool becomes nameless in its operation.